By 1998, Germany's InterCity Express was the world's most advanced passenger train, built on the conviction that engineering could eliminate every source of risk. It had passed every certification test, operated years without a fatal accident, and become a symbol of national industrial pride. One celebrated upgrade had been introduced to solve a complaint so minor it involved glasses vibrating in the restaurant car. That upgrade would kill 101 people. This is the structural autopsy of the Eschede train disaster. On the 3rd of June 1998, ICE train 884, named Wilhelm Conrad Röntgen, departed Munich for Hamburg carrying 287 passengers and 8 crew. At approximately 10:59, the train was traveling at 200 kilometers per hour near the village of Eschede in Lower Saxony. Within seconds, the train that was never supposed to fail became the deadliest high-speed rail accident in recorded history. To understand what happened, you must go back to a design decision made 6 years earlier, the introduction of the BA-064 rubber-sprung wheel. In a conventional solid wheel, rim and body are one forged component. In the BA-064, rubber pads separated the outer steel rim from the wheel body beneath. The rubber absorbed vibration, reducing noise in passenger carriages, and specifically stopping glasses from vibrating on restaurant car tables. German rail authorities approved the tram-derived design in 1991 for speeds up to 280 kilometers per hour after extended test drives. The wheel that entered service in 1992 carried a design pedigree from urban tram networks, where speeds rarely exceeded 60 kilometers per hour. At 200 kilometers per hour, each wheel completed far more rotations per journey than any tram wheel ever had. The approval process evaluated ride quality and surface wear. It did not establish the fatigue life of the inner rim surface under intensified cyclic load. The problem lay on the inner surface of the outer steel rim, a surface the rubber pad arrangement placed under cyclic stress with every single wheel rotation. Each revolution introduced a microcycle of stress, over hundreds of thousands of kilometers. That stress initiated a fatigue crack growing invisibly from the inside outward. Because the crack grew from the inner surface, standard visual inspection from outside the wheel using a flashlight could not detect it. The Fraunhofer Institute, which led the post-crash technical investigation, concluded the BA-064 was an improper application of a streetcar wheel concept to high-speed rail conditions. On the specific train involved, the failing wheel had accumulated roughly 1.8 million kilometers in service. That figure is consistent with peer-reviewed fracture mechanics analysis, which estimated the crack had been propagating for a significant portion of the wheel's operational life. The crack had been growing invisibly, the engineering analysis suggests, for possibly years, through every safety check, every routine service, every certified inspection. Advanced fatigue detection equipment had previously been used at Deutsche Bahn's Munich facility, but was reportedly discontinued because it generated too many false positive error messages. In its place, technicians used flashlights to inspect outer wheel surfaces. Standard procedure, but structurally incapable of detecting a crack growing from inside. The detection method and the failure mode were fundamentally mismatched, and that mismatch was invisible from inside the system that relied on it. 8 staff complaints about abnormal vibrations from the same bogie were recorded in the 2 months before the crash. 3 automated checks reportedly flagged a defective wheel on the same axle the week before the crash, though exact outputs remain unconfirmed. Whether those signals were sufficient to require action was central to the 2003 criminal trial and was never fully resolved. At 10:59 on the 3rd of June, the fatigue crack reached critical threshold. The outer steel rim on the third axle of the first passenger coach fractured and separated. At 200 kilometers per hour, the separated steel rim peeled away and punched upward through the floor of the passenger coach above it. The fragment did not fall clear. It became embedded beneath the carriage, traveling with the train. A passenger saw the metal fragment embedded in the coach floor and reported it to the conductor. Deutsche Bahn policy required the conductor to personally inspect the damage before applying emergency brakes, introducing a delay of several minutes. The train was 6 kilometers past the fracture point and still at speed when the fragment finally met the switch mechanism. The conductor delay meant emergency brakes were never applied before the fragment reached the switch. The window in which braking could have changed the outcome had closed. 6 kilometers from the fracture point, the embedded steel fragment caught inside a trackside switch and flipped it. The switch track diverted rear coaches onto a diverging line, while the front continued straight, tearing the consist apart. The bridge over the track had thin, unreinforced concrete piers, a design never reviewed for switch proximity hazard. The derailing rear coaches struck both concrete piers of the adjacent road overpass, piers thin enough that the impact brought the entire bridge down onto the train. Subsequent coaches concertinaed into the wreckage. Coaches 5 and 6 were crushed beneath the collapsed overpass structure. The front power car separated from the catastrophe entirely, coasting to a stop approximately 2 to 3 kilometers beyond Eschede station. From a single crack, invisible to every inspector, a chain of procedural and geometric conditions had converted one broken component into national catastrophe. 101 people died, the worst rail accident in the Federal Republic of Germany's history, and the deadliest high-speed rail accident anywhere in the world. 88 people were severely injured. Coaches 5 and 6, crushed beneath the collapsed overpass, accounted for the majority of fatalities. The bridge had fallen directly onto the passenger compartments. The rescue operation, approximately 1,844 personnel, 461 paramedics, and 39 aircraft, was the largest mounted in post-war Germany to that date. In 2002, criminal charges of negligent homicide, 101 counts, were brought against 2 former Deutsche Bahn wheel safety officials and 1 manager from the wheel manufacturer. The Lüneburg court heard the case across 53 hearing days. In April 2003, proceedings were dismissed without a formal verdict, and each engineer paid a fine of 10,000 euros. Deutsche Bahn paid an immediate special grant of 15,000 euros per fatality to the families of those killed, a figure widely criticized by survivors as deeply inadequate. Survivors and bereaved families formed Self-Help Eschede in 2000. A civil damages claim brought in 2001 was rejected by the court in 2003. These figure, the fine, the grant, the rejected claim, sit in the public record as documented facts, not as a verdict on the system that produced them. Within weeks, Deutsche Bahn replaced all rubber-sprung wheels across the ICE fleet with the solid monoblock wheels the BA 064 had displaced a decade earlier. The entire German rail network was audited for switches positioned near bridge supports, the specific geometry that had transformed a derailment into a collapse. Train windows were redesigned with breakpoints for emergency egress, and psychological support protocols for rescue workers were substantially reformed. Primary mechanism, metal fatigue in the BA 064's outer steel rim, driven by cyclic stress on the inner surface that no approved inspection method could reliably detect. A tram-derived comfort upgrade was approved without fatigue testing. Invisible cracking grew across hundreds of thousands of kilometers until the rims separated at 200 kilometers per hour. Contributing failures included an inspection protocol blind to inner cracks, a conductor policy delaying emergency braking, an adjacent bridge switch, and pre-crash warnings never translated into replacement. Human consequence: 101 dead, 88 severely injured, Germany's largest post-war rescue operation, a criminal trial ending without a formal verdict, and families whose civil claim was rejected. Eschede was not one person's negligence. It was a system that never questioned whether a tram comfort upgrade could survive a decade of invisible cumulative damage at speed. The upgrade that silenced the glasses in the restaurant car was the upgrade that the train could not survive.